the State University of Iowa in Iowa City comes SUI Newsreel, a 1960 sampling of campus life, of teaching, of research, and student activities. Some of the most dramatic recent developments at SUI were made possible by two remarkable machines like this one being inspected by the man who designed it, Professor E.F. Lindquist, on the right. They are electronic scoring machines which can read, score, analyze, and record test data with amazing rapidity. They can score in hours what it formerly took weeks to do by hand. Each machine can score this stack in 1 hour, 6,000 answer sheets, with each sheet containing up to 14 tests. They are all answers and a yard high. These machines made possible the launching of the American College Testing Program, which may become one of the most important contributions ever made to higher education in America. Designed to determine the potential of entering freshmen for college success, the program has already tested college-bound high school students in states from coast to coast. A nuclear reactor is a recent installation in the Chemical Engineering Laboratory. It's subcritical. An atomic chain reaction is impossible. Professor James Osborne describes the equipment.
This reactor is a safe and very effective teaching device for showing how neutrons behave and the effect of neutrons on matter. We use it in a course in reactor design made possible by this equipment, which was donated to us by the Atomic Energy Commission.
Edmund Cardenas, an engineering sophomore, places a sample of silver foil into the reactor. After a period of time determined by the nature of the experiment, the sample is removed. It's radioactive but safe to handle. Edmund now will determine the amount of radioactivity by placing the silver in a lead shield containing a Geiger counter. This is basically a study of the effect of neutrons on silver atoms. The data is recorded, and the nuclear reactor has helped Edmund Cardenas gain a greater understanding of the world around him. Each year, 10 to 20 students in Advanced Air Force ROTC take part in a flight training program. They learn to fly at the Iowa City Airport with civilian instructors. They study the airplane, from tail assembly to prop. Wayne Kimmel is a senior in business administration and a cadet officer in the Air Force ROTC Corps at Iowa. His instructor is Ted Pratt. Everything is checked out before the solo flight. Wayne will soon be airborne. The ROTC flight training program is the first step toward flying in the Air Force, and the cadets graduate from this plane to an Air Force twin-engine jet. It looks like a good takeoff. While the pupil flies, the teacher keeps a watchful eye on the sky. A three-point landing. After graduation from the university, Wayne will go into the Air Force, where he will apply his flight instruction to a different airplane. This is the age of space, and the State University of Iowa Physics Department has played a pioneering role in the exploration of the upper atmosphere and the vast reaches beyond. SUI equipment has gone up in satellites, rockets, and balloons in search of knowledge about cosmic rays, those mysterious particles which continuously bombard the Earth from outer space. Here, an instrument package is being prepared for a high-altitude balloon flight. It requires detailed and delicate work to get all the tiny components in place and operating. This is the payoff for all the hours of preparation in the laboratory. And this is the payload on its way to the upper atmosphere on a mission of research. Physics department scientists have launched balloons at varying latitudes all the way from the Arctic Ocean to the Antarctic. They watch as the balloon and its valuable cargo gain altitude, and another study of cosmic rays is underway. While balloon flights are better for some types of studies, a rocket is best for taking a quick cross-section survey, a vertical slice out of the sky. Don Enemark prepares a research instrument package for a rocket flight. Don is an engineering senior who has designed instrumentation for cosmic ray flights and participated in launchings. Now he attaches the payload to the base of a Loki, a small research rocket. Balloons and rockets are sometimes combined in a raccoon technique devised by Dr. James Van Allen, head of the SUI Physics Department and an eminent space scientist. Small rockets are lifted through the densest atmosphere before firing, and heights of more than 80 miles have been the result. The nose cone is put in place, and another rocket is ready. Under Dr. Van Allen, the Cosmic Research Program has brought international attention to the State University of Iowa. Many of the experiments aboard the Explorer satellites have been SUI projects, and the radiation belts discovered as a result of the research have been named for Van Allen. I'd like to ask Dr. Van Allen how he feels about some of the implications of space exploration.
Well, I think this is a very broad question. Actually, we can speak with some competence about the technical and scientific possibilities.